Alright, hello my wonderful students. This is part 3 of Foldable number 1. So for this one, we're also going to use two different methods. So on this side, we're going to go ahead and use method 1, and on this side, we're going to use method 2. So we're going to go ahead and get started, do method 1 in blue for the first. So for this one, we have the fourth root of 5 times the fourth root of 125. So for this one, what we're going to do, first things we're going to do is we're going to change this. We're going to go ahead and use the equation over here again. Doing these here, changing it to the radicals and then multiplying it through. And the other one, method 2, remember, it's just going to be leaving it in exponential form and eventually adding it to find what our variable is. But we're going to go ahead and use the formula here that we had earlier. This is the nth root of x to the m is equal to x to the m power over n. Okay, so that being said, we have our 1/4, which is our m over n. So we're going to go ahead and rewrite this one as the n is the 1 is what goes here, so the 5 goes in, and the 1 is actually what goes up here, and the nth root is the 4. The same thing here, we're going to multiply by our fourth root of 125. We're going to go ahead and break down our 125 into our primes. We have 125, and I know 125 is 5 quarters, so I can say 25 cents times 5 is 125, and then 25 is obviously 5 times 5, so these are 3 primes that come onto this root here. So now I know I can multiply this through, so I have the fourth root, because this all member goes under the fourth root. I just realized I should have been doing this in blue, but red is red now. Of 5, for this first 5, times our 3 primes, which is 5 times 5 times 5. And because this is a fourth root, we can go ahead and rewrite this as the fourth root of 1, 2, 3, 4. So 5 to the fourth power. Switch to our blue, and then our fourth root with our fourth power will simplify, leaving us just with 5, and that's our answer. For method 2, we're going to kind of go over here and check this out over here. So now we have the fourth root of, so 5 to the 1/4 power times 125 to the 1/4 power. Because they are not the same base, we can't add the exponential values yet. So what we're going to do, we're going to make them the same base by once again simplifying our 125. I already know because of the one before that 125 is actually 5 times 5 times 5. So that means I can rewrite this as 5 to the 1/4 times our, well, let's go ahead and do 125 to the 1/4 power. But once again, we know that 125 is 5 times 5 times 5. So we're going to do 5 to the 1/4 power times, let's do 5 times 5 times 5 to the 1/4. Now we can go ahead and distribute the 1/4 to each one. 1, 2, and 3. So we're going to have the 5 to the 1/4 times the 5 to the 1/4 times the 5 to the 1/4 times our last 5 to the 1/4. Now that they all have the same base, we can go ahead and add the exponential values. So we have 5 to the 1/4 plus 1/4 plus 1/4 plus 1/4. Parentheses here, so it's 5 to the 1/4, first one, second one, third one, and last one, fourth one. And we know that 1/4 plus 1/4 plus 1/4 plus 1/4, they all have the same common denominator, so we can add the numerators, and 1 plus 1 plus 1 plus 1 is 4. So it's going to be 5 to the 4/4, which is equal to 5 to the first power, because 4 is 1, and 5 to the first power is 5. So these are the two methods on how to solve these different equations. Like I said, certain methods would be easier in a different situation. It kind of just, it's situational. I usually prefer this method here because it's easier to factor or reduce. But if for some reason these are of the same base, these are not, this method would be a little bit easier. Just like I said, it's situational and preference.